starting today's class. Okay. Power related. There is a certain equation which relates to power, force, and velocity for an object. The situation is like this: if we have an object that is moving at a constant velocity, and to maintain that constant velocity, we have to apply a continuous force on the object. Let's say that force is F. So what we need to understand that this is a certain scenario, for example, something like a terminal velocity. Let's say this object is being pushed forward by maybe 5 Newton, where the velocity that we have over here, for that the air resistance on the object working in opposite direction is also 5 Newton. So together these two forces are balancing each other out, and at this, for the upcoming duration of time, we would not be accelerating the object. So this constant velocity will be maintained by the application of this 5 Newton force. And to maintain this velocity, we have to keep applying this force. If we stop applying this force, this object is going to lose its velocity. So the amount, the amount of work that we do for this thing divided by the time for which we are doing this thing can give us the power. That relationship is usually given by this. If I just write in regular forms, power is given by work over time. Work is given by force multiplied by distance moved in the direction of force divided by time. And then if I take this part out, this is over time divided by time. Now, the reason I can convert this thing into velocity is because this is an uniform motion. No acceleration is there. So total distance covered in divided by total time gives us the velocity, which basically gives us the expression for power. So this equation actually tells us that if we want to maintain F uniform velocity of an object, and to maintain that, if we apply a force on the object, the power that we have to provide is given by this expression, P equals to FV. I can also show you the unit conversion for this thing. This equation is actually homogeneous on both sides. The unit for power, unit for force is Newton, unit for speed is, or velocity is meter per second. So I can write Newton meter per second. Newton meter basically gives you joule. Joule per second also gives you watt. So this is actually a homogeneous equation. So that's the key idea for the P equals to FV equation. This equation was derived upon the conception that upon the concept that the object was undergoing at instantaneous velocity. If we do not have this situation, sometimes this equation can be also applied for instantaneous power. Now, let me give an idea for what do I mean by instantaneous power. The concept of the calculation for instantaneous power is not included in your syllabus, to be very precise. But one way I can show it to you like this. Let's say here is an object. We are given an equation for an object that gives us that velocity over time, and let's say the velocity over time has a curve like this. So the object is about to reach terminal velocity, and if the question asks you that if the question already tells you that the object was being pushed by a forward force of, let's say, 3 Newton, then what is the power at t equals to, let's say, power equals to what at maybe t equals to 2 seconds. So what you have to do, if you have a graph like that, you just calculate from this part, find out the velocity from this point, and then you can use that velocity and directly use this equation that P equals to FV. So that will be 3 multiplied by that velocity that you get from the graph. That gives you the instantaneous power of that that is used to achieve that motion at that time instant. So if we have situations with graphs, this equation P equals to FV can be also used to find out instantaneous power requirement for a certain variable for a certain accelerating motion. So that's also possible. It's not very common, but not impossible. It is possible that we can calculate the instantaneous power. Yeah, Hasan, go ahead. Bolo.
স্যার এইটা তো ফোর্সটা তো কনস্ট্যান্ট ফোর্সটা তাই না স্যার, যেটা রেজিস্টিভ ফোর্স ইকুয়াল টু দ্য রেজিস্টিভ ফোর্স, তাই না?
Yes.
আর স্যার আরেকটা কোয়েশ্চেন ছিল স্যার, এটাতে যদি স্যার এটা একটু অন্য জিনিস নিয়ে স্যার, এটা একটু পরে জিজ্ঞেস করি স্যার।
আচ্ছা ঠিক আছে, সমস্যা নেই। So let's go ahead with the problems that we have at hand. I have a list from one of our classmates, so I'm going to pick up that list first and go for all the problems that within that list, and then we'll slowly go for further problems as well.
স্যার মোমেন্টাম থেকে আরেকটা কোয়েশ্চেন ছিল স্যার, ছোট একটা, স্যার ওটা জিজ্ঞেস করে নিই।
বলো।
স্যার ওই যে যদি একটা কনস্ট্যান্ট মোমেন্টাম হয় স্যার একটা অবজেক্টের, তাহলে এটা মানে কনস্ট্যান্ট রেট অফ চেঞ্জ অফ মোমেন্টাম, তাহলে ওটার গ্রাফটা কেমন হবে, ভেলোসিটি টাইম গ্রাফটা?
আরেকবার বলো। যদি আমাদের
স্যার যদি যদি আমাদের কনস্ট্যান্ট রেট অফ চেঞ্জ অফ মোমেন্টাম হয় স্যার, তাহলে ভেলোসিটি এগেইনস্ট টাইম গ্রাফটা কেমন হবে?
তুমি নর্মালি চিন্তা করো, if your rate of change of momentum is constant, which means your force is also constant, which is basically resultant force. If resultant force is constant, that would essentially mean acceleration will also be a constant. So the rate of change of velocity, so del v by del t, do you on delta v versus t or delta v over t? মানে
স্যার মানে ভেলোসিটি এগেইনস্ট টাইম।
আচ্ছা, so if you want to have velocity against time, this should be a straight line. I'm not gonna say passing to the origin, because I don't know at
জি
what was
স্যার,
that.
এবার বুঝছি স্যার, আমি তখন মিলাইতে পারিনি স্যার, যে রেট অফ চেঞ্জ অফ মোমেন্টাম বলছিল তো।
Sure, no problem. বুঝা গেছে কিনা?
জি স্যার, বুঝে গেছে স্যার।
Beautiful. So এখানে I have this three questions. আচ্ছা, this is MCQ number 24, right, Mithila?
Yes, sir.
আচ্ছা, দেখতেছি আমি। এটা কি ফার্স্ট ওয়ার্কশিটের?
হ্যাঁ স্যার, 1.1।
আচ্ছা, দেখে দিচ্ছি আমি, ডোন্ট ওয়ারি। কই জানি আছে এগুলা? আচ্ছা, এখানে। Open 124. Acha, if we have a look at this question 24, this question tells us that which definition is correct and uses only quantities rather than units. So we have to look out for a correct definition, which means the concept of the definition should be correct, and you should also use not any specific unit. I mean, if it can use per length, it can use per volume, but it shouldn't use per meter. It shouldn't use per meter cube. It shouldn't use per kg. It can say per mass or unit mass. That's the type of variation that we're looking for. So first thing, the A option says density is mass per cubic meter. So they have used a unit over here. This is not essentially wrong, but the actual definition of mass is unit per. So the actual definition of density is that density is mass per unit volume. Now the useful unit for density in SI unit, we use kg per meter cube, but we can also use gram per centimeter cube as well. That's also acceptable. In many cases, it is also used. For example, water has at 4 degrees Celsius, water has a density of 1 gram per centimeter cube, which is also 1000 kg per meter cube. So that's not, that definition is okay. It looks okay, but it is using a certain unit for its expression. That's why we are not choosing it as the correct option. Number B says potential difference is energy per unit current. Potential difference is energy per unit current. So it is saying that potential energy E equals to, sorry, potential energy, no, potential is potential difference, sorry, potential difference is, so V is E divided by I. No, this is not also correct, because if I do the cross multiplication of this whole thing, you're gonna get E equals to VI. But we know from our O levels that this is not a correct equation. We have learned in our O levels that power is given by V into I, not energy. So the correct equation should have been energy into time should be given by voltage into current. বুঝা গেছে?
জি স্যার।
এনার্জি পয়েন্ট এটা বাদ। তারপর সিতে বলছে pressure is force per unit area. This apparently is the correct definition as per this standard. We are not using units. The expression is also good. Speed is distance travel per second. Once again, they have used the second part, second over here. So that's why we are not choosing. C is the correct option. Next problem that we have is this one. A loudspeaker produces a sound wave of constant frequency. Outline how a cathode oscilloscope may be used to determine this frequency. Okay, this is measurement quantities. Question number 23, paper 2. Look at it. Okay. This is question. A loudspeaker produces a sound wave of constant frequency. Outline how the cathode oscilloscope CRO may be used to determine this frequency. Okay. So a couple of things that we have to draw over here. First of all, we need to show a loudspeaker that is capable to produce some sound. We can choose to draw a loudspeaker and only say that it is producing sound, but a good way should be you draw a loudspeaker and connect it with a fixed AC source. Because the way loudspeaker produces sound, the structure of loudspeaker that we've learned in our O levels, these are all the vibration is controlled by the frequency of the alternating current. So that would be a good thing. I'm not sure what the examiners are looking for, but if I was answering this question, this is how I might actually go for. Let me show you my preferable version of drawing, and then I'll explain why I prefer that option. So if I was drawing this, I would draw a loudspeaker that is connected to a AC source. Might as well give some switch over here because that would be required. Taki, we don't need your video. And then we can have the
স্যার ইউসুফ আমি না
বুঝি নাই
আমার ভিডিও ছিল না ইউসুফের ছিল
আচ্ছা sorry my bad Yusuf, we don't need your video. Acha. So in front of the loudspeaker we're gonna keep our microphone and we have to label everything. This would be labeled as loudspeaker. You don't have to label this part. These are actually very basic circuit symbols. You have to label this microphone and two wires are gonna come out of that microphone. If you draw two wires, this is okay, or you can choose to draw one wire. I'm going to show you both of the connection types. One thing that we can do is, okay, we're going to draw the loudspeaker over here, CRO over here. This is going to be the big part of our drawing. One part is going to be the display. Within that display, these are supposed to be straight lines. I cannot draw with whiteboard because Microsoft MS Whiteboard is doing some magical things of its own, which is sometimes not so useful. So you have to draw the axis system, and the two ways you have to show over here two different connection point and label them as Y gain. So we put these things in the Y gain connection point, and we'll have some knob over here, which should be the Y gain knob. Beside that, we can have the time base knob. So you can write over here time base. Writing out down time base is optional. Then you can have some other optional buttons as well. For example, you always have something called X shift and Y shift. We can also draw those knobs if you want. If you cannot accommodate your writing within the box, you can just pull it out arrows and you can label them outside. Equally acceptable, no big deal. Now, what is important, the two different type of connections that you can show. One connection can be, you can show two wires coming from the microphone getting connected on the two parts of the Y gain. That's one option. You can do that. Or you can draw one wire from the Y gain and draw another wire out of the Y gain and label that to be connected with the earth wire. This is also equally acceptable. Some microphone does give out two different wires. Some microphone gives only one wire, which should be compared with the 0 voltage, the earth connection. Either of this connection is acceptable. Typically, examiners appreciate the first one. They appreciate both of the wires to be connected to the CRO. So you can choose to draw, but drawing this is also equally acceptable. So I'm gonna draw the first version over here. And once we have this thing, and because the switch is closed over here, the loudspeaker is actually making sound. So the sound will be captured by the microphone, and that should give us some graph over here. Now, as far as I remember, the way the examiner, the mark scheme for this question was recommended that within the CRO display, there should be at least 2 waves. I'm not sure, but so far I remember that it had this kind of a requirement in the CRO. I might be wrong, or this might be actually for some other question. But for the sake of safety, what is always recommended that you draw at least 2 complete waves on your serial screen. So let's say I'm going to draw a bit more than 2. So like that. The waves should be visibly sinusoidal wave and of equal length on both sides. And that's pretty much it for your figure. You just label this thing as CRO, cathode oscilloscope. All the things are written over here, and label these 2 names over here. This is a microphone. This is the loudspeaker. There's a circuit diagram. Circuit diagram structure to বুঝা গেছে কিনা? But description আমরা কি লিখবো? Let's say because this is a 4-mark question, you can assume that the circuit diagram should have 2 marks in it, and the description might have 2 marks in it. Now, have a look at the question. The question says outline how a cathode oscilloscope CRO may be used to determine this frequency. So this is asking us to how to calculate the frequency. And frequency calculate করার বুদ্ধি হচ্ছে that we have to look on the cathode oscilloscope. We have to take 2 observations. I'm going to draw multiple other things over here which you shouldn't draw, but I'm trying to highlight this part. First thing we should take a look is that what is the time-based scale within on the skin on the cathode oscilloscope. You should take a measurement of that. If it is 2 milliseconds per centimeter, it may be 4 milliseconds per centimeter, it might be 10 milliseconds per centimeter. Whatever that is, we should take that reading from the time-based knob. And then we should count how many centimeters does one full wave or one complete cycle covers on the screen. So we have to take a look for the length in centimeter for one full cycle, and then we have to see what is the time-based scale. So then we can calculate. If I was writing this, I would write that we observe the time-based setting from the CRO, and also measure in centimeter the length, the horizontal length that one full cycle in the screen covers. Then we calculate that. Then the time period. I'm going to write time period, comma, capital T. I'm using this comma because I want to write less afterwards. Time period capital T equals to time base multiplied by length of one cycle. So এটা হচ্ছে তোমার actually equation. এখন এটা মিলিসেকেন্ড পার সেন্টিমিটার হতে পারে, এটা সেকেন্ড পার সেন্টিমিটার হতে whatever, এই দুটাকে মাল্টিপ্লাই করলে আমরা একটা টাইম অ্যামাউন্ট পাবো। Then frequency comma small f equals to 1 upon time period is calculated. এই হচ্ছে total procedural observation. So তোমাকে specifically দুটো observationের কথা গুছায় লিখতে হবে, that we have to take a reading from the time based knob, যেটা হচ্ছে এইটা, and we have to also have to look for the length of one cycle measured in centimeter. Only writing length of one cycle is also good, but measured in centimeter is usually a better way, because typically all the oscilloscopes that we use typically in our laboratories which you haven't used yet. Because all the things that we use, they usually always give their unit in some sort of millisecond per centimeter unit. That's the most common unit on the time-based settings. So if you write in centimeter unit, that would be a better thing that the examiner should know that you really know how to handle an oscilloscope. This would be how I would write my answer. But just because this is a descriptive question, I'm going to look at the mark scheme and have a look what they have for us. This is question number 23.
স্যার এখানে y ইনপুট টার্মিনাল ওয়ার্ডটা ইউজ করা যাবে
কোনটা?
y ইনপুট টার্মিনাল
Y gain into terminal মানে?
স্যার y ইনপুট টার্মিনাল
আচ্ছা, আমি তো অলরেডি ফিগারে অলরেডি দেখাই দিছি যে কানেকশন কিভাবে হয়। আচ্ছা, আমি একটা জিনিস বলতে ভুলে গেছি। এই ডেসক্রিপশনের শুরুতে আমি একটা জিনিস লিখে নিব দ্যাট উই কানেক্ট অল দ্য সার্কিটস অ্যাজ শোন ইন দ্য ফিগার। এটা আমরা বাই ডিফল্ট লিখে নিব। আমরা এই পুরো সার্কিট ডায়াগ্রামটাকে আর ওয়ার্ডে ডেসক্রাইব করব না। I forgot to mention that. We should write at the very beginning, before everything that I said, that we connect the circuit as shown in the figure. এরপর তুমি আস্তে আস্তে মেজারমেন্টের কথা লিখতে হবে। এখানে আমাদের y ইনপুট গুলা কোথায় কানেক্ট করতে হবে সেটা অলরেডি সার্কিটে একে দেখানো আছে। সো এই জন্য জিনিসটা আর ফার্দার এক্সপ্লেইন করা লাগবে না। সো y ইনপুটের কথা তুমি চাইলে মেনশন করতে পারো। You can write that we connect the two microphone wires in the two y inputs, but make sure that y input has no part within this equation. That's very important. Examiners will look out for the most common mistake, that whether the students bring about anything about the y gain or the y input thing in the time period calculation, because time period calculation is by no means related to the y gain or y inputs or y shift. That's what the examiners are.
স্যার আরেকটা ছিল স্যার, এখানে আমি লিখছি যে we multiply the number of horizontal divisions from the start of the wave till the end and multiply it with the number of with the time base. ওইটা লিখছি স্যার, like instead of writing the frequency equals to 1 by time period.
Tomar, we measure the number of divisions. If you write it in terms of divisions, then you have to say you are missing the words for one cycle. You said for one cycle লিখছো?
The start and end of one wave.
One, then you should write one wavelength.
Yes sir. Yes sir.
Either you write one wavelength or you write one cycle. This specifies exactly one full sinusoidal wave, because if you write one wave, because a continuous wave which is given for a small section is also can be called one wave. So let's have a look at the mark scheme. What they have to tell for us. Current microphone terminals of loudspeaker to Y plates of CRO. This has to be mentioned. So we connected with the Y inputs. It should be okay. Adjust CRO to produce steady wave of 1 or 2 cycles wavelengths on screen. So either you write this description in write these words in your description, or if wavelengths are seen on the screen, either of these two things is going to give you the one. These are the 2 marks for the circuit diagram. Measure the length of the cycle or wavelength lambda and note time base b, frequency equals to 1 upon lambda b. They have given 1 upon lambda b because they didn't go for the time period calculation, but they have written over here as well. Assume b is measured in second per centimeter unless otherwise stated. If statement is measured f equals to 1 by t, then the last 2 marks are lost. আচ্ছা, বলতেছে এখানে মানে এই কথাটা মানে কি? If I mean what they have basically written is exactly what I have said over here. But if some student only write without mentioning this formula, that you have to multiply the time base and the length, if you don't mention about that, if some student exclusively write that we measure the time period and then frequency equals to 1 by time period, if someone only writes that, then they're not going to get the calculation mark, because the CRO does not hand you out the time period by any display or by any measure, by any direct method. You have to take 2 observation, multiply them, and only then can you get the time period. So writing this statement exclusively will score you 0. But if you go for the way that I showed you, that you first mentioned that the time period is this much and then frequency f equals to 1 by t is calculated, this is equally accurate. Or if you don't want to write, if you want to obliterate or discard the word time period from your answer, you can directly write that frequency is calculated by 1 divided by time base into length of one cycle. That's also okay. But you have to provide this information that time period is measured by time base into length of one cycle. That is the important bit. বুঝে গেছে?
জি স্যার।
আচ্ছা, examination report আমরা একটু দেখি, just so that we understand what kind of mess up the were common. Answers were in general disappointing. Okay. Candidates were expected to state that the microphone or loudspeaker is connected to the Y plates of the CRO. Some indication of the adjustment of the CRO was expected along with the measurements made. The formula for the calculation of the frequency should be given. Candidates should be encouraged to draw diagrams that indicate the necessary information and not rough sketches that lack accuracy. All too often, the CRO was shown as a box with one lead from a microphone going to an unlabeled point on the box. The waveform drawn frequently had varying amplitudes and distance for one cycle. Okay, so they're expecting some amount of accuracy within these parts. So what they are looking for is that within your drawing, things should be properly labeled. So I labeled over here Y gain, and I labeled one knob, I labeled time base, and didn't draw any knob, and draw you on the knob over here. They are expecting, I'm pretty sure they're expecting a ruler to be used for all the places where straight lines are to be exist. And then also this wave that should be drawn over here should be at least by eye of equal wavelength on both sides and equal amplitude. I mean, you should not just bulldoze
Draw
over
by
the drawing.
free hand.
You should definitely draw by freehand because you don't have an instrument to draw sine curve in your figure. But what the examiners are looking for is that they're expecting that for you to draw waves that has uniform amplitude on both sides, and also the cycles should be equally length on both sides, or at least half the cycle should have half the length of the other side. I mean, drawing a wave that looks like this is no, drawing a wave that looks like this is not actually a good idea. I mean, you don't have symmetry, neither do you have equal amplitude on both sides. This is just plain wrong. I mean, the examiners would not appreciate that. They are looking for some accurate drawing. That's what they mean. Make sense? I hope. So the next question that we have within this sequence was this one. So the volume V of the following liquid is 35, P2 at 35. Let's have a look. There it is. The volume V of a liquid flowing in time T through a pipe of radius R is given by the equation V by T equals to pi PR to the power 4 divided by 8CL, where P is the pressure difference between the ends of the pipe of length L, and C depends on the frictional effects of the liquid. An experiment is performed to determine C. The measurements are made are shown in figure 1.1. So V by T has a value, P has a value, R has a value, L has a value. Calculate the value of C, calculate the uncertainty in C. Okay, I get the question. Now what you provided us is with the calculation. আচ্ছা, এখানে প্রবলেমটা কোথায় হয়েছে?
স্যার বি তে।
মানে আনসারটি ক্যালকুলেশনতে ঝামেলা হয়েছে, এটা মিলছে?
স্যার হ্যাঁ এটা মিলছে।
ওকে, দেখাচ্ছি আমি, নো ওয়ারিজ। কি অবস্থা পেশেন্টের? আচ্ছা, এখানে আমার ইকুয়েশন হচ্ছে V by T equals to pi PR to the power 4 divided by 8CL. We are trying to calculate the value for C. তাহলে এখানে C এর ইকুয়েশনটা আমি আগে লিখি। C এর ইকুয়েশনটা হবে হচ্ছে pi PR to the power 4 divided by 8L multiplied by 1 by V by T. এই হচ্ছে C এর এক্সপ্রেশন। তাহলে এখান থেকে যদি আমরা uncertainty equation লিখি, this might as well look like del C by C, might as well give a vertical line, it be equals to del P by P plus 4 times, আচ্ছা আমি একটু জুম ইন করি, তাহলে আমি একটু বড় করে লিখতে পারি, 4 times del R by R plus del L by L plus del of V by T divided by V by T. আছে পাইছি এই হচ্ছে টোটাল ইকুয়েশন। সো এখানে আমরা এখন ভ্যালুগুলো আস্তে আস্তে বসাতে থাকি। p হচ্ছে 0.5 divided by 2.50 plus 4 times 0.01 divided by 0.75 plus 0.01 divided by 1.20 এখান থেকে তোমার ফ্র্যাকশনাল আনসার্টেনিটিটা বাইর হবে whatever that number comes, therefore uncertainty would be equals to that whole thing whatever that is multiplied by whatever you got over here, এটা ফাইনালি এখানে লিখবা, কারণ এটা ক্যালকুলেশন করে দেখো কত আসে। আমি মনে হয় এখানে একটা পার্ট বাদ দিয়ে ফেলছি, ভুলে ডেল এল বাই ডেল এল লিখি নাই, তাই না? হ্যাঁ, এখানে কম্পোনেন্ট আছে 4টা, আমি লিখছি 3টা। সো আমি এইটা মিস করে ফেলছি, সরি, এটা আমি পরে লিখতেছি। অ্যাড করে দেখো এগুলো কত আসে। I'll try with my own calculator. Where is that? Hi. Let's see. 105 plus 2.5. আমার আসছে
Sir,
0.856667। আচ্ছা, পুরোটা মিলছে এখন?
হ্যাঁ স্যার,
এটা মিলেছে স্যার, বাট স্যার এসএস কতটুকু লাগতো স্যার? আমরা
বুঝি নাই।
ডেসিমাল পয়েন্ট কতটুকু রাখবো স্যার?
Well, that's pretty simple. এটা যতটুকু আসে এটা তুমি এখানে তো আমরা দুইটা কোয়ান্টিটিকে আর একসাথে লিখতেছি না, মানে আমরা সি প্লাস মানে হচ্ছে আমরা সি প্লাস ডেল্টা সি কি হলো, সি প্লাস ডেল্টা প্লাস মানে ডেল্টা সি তো একবারে লিখতেছি না। যদি একবারে লিখতাম তখন যেটা হইতো যে আমাদের 10 এর পাওয়ার ম্যাচ করতে হইতো, তারপর সি এর ডেসিমাল পয়েন্ট আর ডেল্টা সি এর ডেসিমাল পয়েন্ট ম্যাচ করে লিখতে হইতো। দ্যাটস দ্য স্ট্যান্ডার্ড প্রসিডিউর। বাট যেহেতু আমাদের এখানে সেই স্টেপটা করতে বলে নাই, শুধু আনসার্টেনিটি লিখতে বলছে, সেটাকে তুমি জাস্ট স্ট্যান্ডার্ড ফর্মে লিখবা 3SF ভ্যালু ইনটু 10 টু দি পাওয়ার সামথিং হোয়াটএভার দ্যাট ইজ। বাট যদি ইভেন্চুয়ালি আমাদেরকে দুটাকে একসাথে কম্বাইন লিখতে বলে কোথাও, মনে করো পরের কোশ্চেন যদি বলে যে নাও রাইট দ্য হোল থিং, তখন আবার 10 এর পাওয়ার ম্যাচ করে ডেসিমাল পয়েন্ট ম্যাচ করে ডেল্টা সি লিখতে হইতো।
আর স্যার এখানে যে তো শুধু আনসার্টেনটি, আই মিন মানে অরিজিনাল সি এর ভ্যালু তো লাগবে না না স্যার? শুধু আনসার্টেনটি পার্টটাই তো এখানে লিখবো।
ইয়েস। আচ্ছা, এটা গেল। এরপর আরো কয়েকটা প্রবলেম দিচ্ছিল এখানে। এটা কোন
স্যার
ওয়ার্কশিট?
কয়টাই ছিল।
হ্যাঁ
স্যার এই কয়টাই ছিল প্রবলেম।
আচ্ছা, ঠিক আছে, ফাইন, ওকে। So I'll take more problems from other students as well right now. If you have attempted anything and that you need me to
জি স্যার।
discuss, বলো।
স্যার কোলিশন স্যার মানে 2.2 এর।
হ্যাঁ, বের করতেছি, এক মিনিট। MCQ
জি স্যার।
Okay. And 2.2 air.
Sir, 40.
This is a nice question. Good pick. I'll help you solve this. There is a certain thing that is wrong to assume, and that's why this question can prove sometimes give you wrong answers. So MS whiteboard আবার কি আছে এখানে আবার ব্লু বার আসছে কোথা থেকে আচ্ছা never mind আচ্ছা let's look at this question and try to make sense of this question. A lead pellet is shot vertically upwards into a clay block that is stationary at the moment of impact but is able to rise freely after impact. মানে বেসিক যে আইডিয়া মনে করো হচ্ছে দুইটা প্ল্যাঙ্কের উপর বসায় রাখছে নিচে থেকে একটা লেড পেলেট শুট করা হবে এটা কালেকশন করার পর লেড পুরো ক্লে ব্লকটা উপর দিকে হালকা লাফ দিতে পারবে. The pellet hits the block with an initial velocity of 200 meters per second. It embeds itself in the block and does not emerge. Important information, they are together stuck. How high above its initial position will the block rise? Mass of pellet 5.0 gram, mass of clay block 95 gram. Achha. Here's the thing. If we use the concept of conservation of linear momentum for this question, we can find out the answer perfectly. And that is the correct way to approach this problem. The apparently correct, misleading, and wrong process to attempt this question is by considering energy. Let me show you the wrong way, which is going to look pretty lucrative to attempt because it is a very simple calculation. This wrong way is by considering energy. I'm going to tell you why this is wrong. So the idea is that when the lead pellet was incoming, it has some kinetic energy. It got embedded within the stationary block. So let's assume that all of the kinetic energy would be transferred to the combined mass kinetic energy over here. So it's gonna rise up to the height using the same amount of kinetic energy. So K equals to GP. You just simply go ahead to calculate the height. So that equation might look like this, that if I use 5 gram, because it's gram everywhere, 5 half into 5 into 200 squared should be equals to 95 plus 5 GH. That's the equation, which looks very lucrative. And you can try this, but trust me on this one, this is going to give you a wrong answer because this consideration is not valid. The reason this consideration is not valid is that whenever the lead pellet would get embedded within the stationary clay block, kinetic energy will not be conserved. Kinetic energy will not be conserved, which means you would have to spend some energy of the incoming lead pellet, kinetic energy of the incoming lead pellet, that would be converted into deformation energy because you have to actually penetrate within the stationary clay block. So you have to displace some clay molecules, some clay particles out of the original position permanently. That energy has to come from the kinetic energy of the lead pellet. So because kinetic energy will not be conserved, all the kinetic energy cannot be converted into all the GP. So that's why, although it looks very lucrative solution, this consideration would be wrong because energy in this case, kinetic energy in this case, will not be conserved. This is the most common wrong attempt many students do and get a wrong answer. The correct way to do this problem is to go by two different steps. First, we have to find out what would be the combined upward velocity of this object. And then we have to go by equation of motion to find out its maximum height. So let me show you piece by piece. 5 into 200 plus 95 into 0 should be equals to 5 plus 95 into V. This is the equation for conservation of linear momentum. So this ultimately gives us V equals to 1000 divided by 100, which is equals to 10 meters per second. So this V actually means the final velocity after the collision has happened, which is going to work as the initial velocity of rise for this combined object. So what we have to consider at this instant, that this object is going to now start
Sir.
to rise up by bolo.
স্যার এখানে স্যার গ্রামে তো দাও কিলোগ্রামে কনভার্ট করা লাগবে না স্যার?
Now I have used gram on both sides so they can cancel out each other. If you want to convert them to kilogram, you can do that, but ultimately you're going to get the same answer. I just tried to make it simpler because there is gram on both sides. We can do that. So,
Okay, sir. Yes, sir.
so after the collision, the initial velocity of the combined object is going to be 10 meters per second. Using this velocity, the combined object is going to start to rise upwards, and eventually at the final point, this is going to come to rest. That's what we mean by maximum height. So at this point, the final velocity should be 0. Initial velocity in this case is 10. So if I use the term V over here because this was the final velocity for the collision state. So what you need to understand that the combined final velocity after the collision would be the initial velocity of the rise. Let's say this word again. Combined final velocity after the collision will be the initial velocity of the rise. So initial in this case, so this 10 meters per second that we just calculated out should be the initial velocity of rise. If we write the equation for v square equals to u square plus twice as, you can write 0 square because this is the for the rise scenario equals to 10 square plus 2 into minus 9.81 multiplied by h. Now simply calculate out your h from here, which would be 100 divided by 2 into 9.81. Whatever you get from here is your correct response. দেখো কত আসে?
Sir, 5.0968.
Okay, so 5.1 approximately into SF is the correct response. বুঝা গেছে?
জি স্যার, বুঝছি স্যার।
এটা কেন হবে না সেই লজিকটা ধরা গেছে?
জি স্যার।
তুমি এটা দিয়ে ট্রাই করছিলে, রাইট?
না স্যার, আমি আরো আমার সায়েন্সে ডি পাইছিলাম স্যার, আমি কোন জন্য একটা ফর্মুলা দিয়ে ডিরেক্টলি করতে গেছিলাম।
আচ্ছা ঠিক আছে, ডিরেক্টলি করা যাবে না এই অঙ্কটা করতে গেলে এই টু স্টেপ মেথড দিয়ে করলে এটা কনভিনিয়েন্টলি করা যাবে, কারণ এটাকে কোনোভাবে এনার্জি কনসিডারেশন দিয়ে করা যাবে না বিকজ this math cannot be attended for by energy consideration because we do not know how much of the kinetic energy actually got absorbed as deformation energy. We don't have that information. If we had that information, then we might be able to do that by subtracting a small portion out of it and then converting it into GPE to KE. That would be possible. Not relevant for your syllabus, but we don't have enough information for within this question to attend this problem with energy consideration because the lost amount of energy is by no means mentioned. But you have to be understanding within your head that whenever the two objects are getting combined, in a kinetic energy will not be conserved. It's a key idea which you cannot miss out. তারপর anything else?
2.4 number 43.
2.4 হ্যাঁ অভিক বলো।
2.4 number 43.
2.4 এর 43। আচ্ছা এইটা একটা ভালো এমসিকিউ, এটা কি পারছো সবাই? আমি তোমার প্রবলেম দেখাচ্ছি, আমি জাস্ট এটাতে চোখ আটকে আছে। এমসিকিউটা পারছো সবাই? This is 2.3 10.
নো স্যার।
আচ্ছা এমসিকিউটা খুব সিম্পল, আমি সিম্পল পার্টটা বলে দিচ্ছি। If you try it again, you should be able to do this. This thing time t1 and time t2. These are not, time t1 is the time from time 0 to time t1. Time t2 is the time from time 0 to this point. Time t2 is not the time for the falling height of h. Time t2 is the total time it takes for it to fall the entire length of x plus h. So understand that, and then the whole thing is going to work out very simple for you. You have to write one equation for the x height, and then you need to write one equation for the x plus h height. First equation is going to be in terms of t1, second equation is going to be in terms of t2. Initial velocity is 0, so you equate both of these equations, you should get a good looking equation over here. Not to mess up the whole understanding, because the most common mistake the students do for this question is that they don't read the question well. They just look at the figure and apparently they believe that they have got all the information. So they assume that the time it takes for it to fall through the x height is t1, and the time it takes for it to fall through h height is t2. That's not the case. The question told us very specifically that both of the times where amount of times which we started to count at the instance of dropping the ball. So এইটুকু বুঝলে বাকিটুকু অ্যাটেম্প করলে পারবা, যদি ম্যাথমেটিক্যাল এরর না হয়। ট্রাই করে দেখো, যদি না পেরে থাকো আমি না পারলে আবার দেখাই দিব নরমালি। অভিক বলছিল 2.4 এর 27।
না স্যার 43।
2.4 এর 43। নাইস কোশ্চেন, গুড পিক। দেখাচ্ছি। Let's have a look. This question tells us that a student throws a ball in the positive direction vertically upwards. Very important. We're considering upward as positive. The ball makes an elastic collision with the ceiling, rebounds and accelerates back to the student's hand in a time of 1.2 seconds. Try to understand the meaning of this word. The ball makes an elastic collision, which means no kinetic energy is lost. The ball makes an elastic collision with the ceiling, rebounds and accelerates back to the student's hand in a time of 1.2 seconds. Which graph best represents the acceleration of the ball from the moment it leaves the hand to the instant just before it returns to the hand? Achha. Let me give you this idea very well. Weight of any object works downwards. In this case, upward was considered positive. So as long as the ball is not in contact with the hand, not in contact with the roof, ceiling, as long as it is only going through the atmosphere, it would have a constant minus 9.81 acceleration, whether it is going upwards or it is going downwards. Try to understand that part first. As long as it is going upwards, acceleration is minus 9.81. As long as it is falling downwards, acceleration is also minus 9.81. There is absolutely no variation for that, because we are essentially considering air resistance negligible. So if you can appreciate that part, Acha, Hasan asked me a question that acceleration vector and velocity vector same direction e hole acceleration hobe kina. Well, Hasan, here's the thing. Acceleration vector and velocity vector doesn't have to be in the same direction, doesn't even have to be in the same, they don't have to be in the same direction. Acceleration will always be aimed in the same direction as the force applied, but it could work in any direction irrespective of the initial velocity of the object. If the acceleration is working along the same straight line of the initial velocity, that acceleration is going to cause some value change of the initial velocity. But if the acceleration is working at some angle with the initial velocity, that acceleration will cause some direction change as well along with the value change. If the acceleration that is applied is perpendicular to the initial velocity, that will exclusively change the direction. The scenario that we go for circular motion, we call it centripetal acceleration. So acceleration can be applied in any direction, that doesn't matter.
স্যার যদি অ্যাক্সেলারেশন ভেক্টর আর ভেলোসিটি ভেক্টর সেম ডিরেকশনে হয় তাহলে আরো তাড়াতাড়ি মুভ করবে না স্যার, সেম লাইনে যদি সেম ডিরেকশনে হয়। আর যদি অ্যাক্সেলারেশন ভেক্টর আর ভেলোসিটি ভেক্টর অপোজিট ডিরেকশনে হয় তাহলে স্লো ডাউন করবে স্যার, তাই না স্যার?
Precisely, and this is why you have to choose your words carefully. What you are trying to ask me, if the acceleration vector and the velocity vector are in the same direction, same alignment, then the object will speed up. If you write that, then the object will accelerate. Mentioning that an object accelerate actually gives you a vast range of possible outcome. An object accelerating could mean it is increasing in speed, it is speeding up, it is slowing down, it is changing direction, maybe any two of those simultaneously. An object accelerating can have multiple different meanings. But if you want to what you wanted to mean is that the object is going to speed up. So you better write that exclusive word, that when the velocity vector and the acceleration vector are in the same direction, object speeds up. When they're in opposite direction, object slows down. That's okay.
জি স্যার, বুঝছি স্যার।
You have to choose your words precisely to articulate your concepts properly. So this is the first thing. সেটা হচ্ছে that because we are considering upward positive, and for the entire duration, as it is not in collision with the ceiling or not in touch with the hand, there will be a negative acceleration, which means A and B are out of question. We do not choose any of these. So our only possible choices are C and D. Now, there is a very simple way to choose the correct answer. You do understand that we are considering error resistance negligible, which means the amount of time it should take to reach to the ceiling must be same the amount of time it takes to come back to the hand. In option choice C, these two times are not equal because this spike definitely represents the acceleration, the collision. So obviously you should choose D because they have made the mess up with the amount of time for rise and fall. The choice actually becomes very easy. So regular students who could simply understood that the G should be on the minus side should be able to choose the correct answer simply by observation. However, so D is the correct option. You can choose it very easily, but I'm going to help you understand better that why this spike should be downward in the downward direction. I mean, what if the question had this is at the mid, this one at the middle in the center, and this one at the middle at the downwards? Then what? Then which one should you choose? Here's the deal. Try to understand. Let's say this is the ceiling. Before the ball hits the ceiling, it experiences a downward acceleration of G. For the duration, the collision goes on. The weight still works, so G is also there, and the ball would get an additional amount of downward acceleration because of the force, because of the collision, which means the downward acceleration for the duration of collision, for the duration of contact with the ceiling, will be bigger. The downward acceleration will become bigger, which means as long as it is rising, if a constant acceleration, as long as the collision happens, contact happens, your downward acceleration is going to be bigger than the G value. And when the collision finishes and the ball gets released from the ceiling once again, the minus G keeps on happening. That's why the spike is happening downwards, because this graph is showing us the acceleration experienced by the ball, not the ceiling. Not the ceiling, the acceleration experienced by the ball. That's why it has to be downwards. So I gave you two different logics over here, that both the rise and the fall time should be equal. That's one way to easy check for the correct option choice. And as for the duration of the spike, it should be downwards, because hitting with the ceiling actually means it actually has downward acceleration gets spiked. However, considering the same information, you can also understand that if we drop a ball from our hand onto the ground, and the ball does elastic collision with the ground, quite unlikely, but let's say it does, and then it jumps back to the same height. And in that case also, this graph of acceleration versus time should also happen pretty much like that. For the duration of falling and for the duration of rising, you should have minus 9.81. That's for sure. Now, what I'm trying to ask you, in which direction should this spike be? In which direction should this spike be for the collision when it is making a collision with the ground?
Sir, upward.
It should be upwards. Now, definitely, because if this is downwards, this should be definitely upwards. Good. Now, what I'm trying to ask you, that should this upward acceleration go beyond past the x-axis, or should it be below x-axis? What do you think?
Stay below x-axis.
below x-axis হবে নিচের দিকে হবে না স্যার
স্যার অ্যাবভ হলে তো স্টপ করে ফেলবে না, or above হতে হবে to generate enough force to bounce it back.
Here's the deal. This acceleration, whether this acceleration should cross the x-axis, I mean, should the acceleration be like that, or should the acceleration be like that? That was my question. Which one should it look like? There is no hard and fast rule that you can choose any of these exclusively. How much the acceleration is going to be is largely dependent upon at what force the object is hitting the ground and what is the mass of that object. Try to understand. If you drop a steel ball from the roof of a 5-story building, the upward force is going to be huge, it's going to be massive. If you drop a steel ball from a 5 centimeter height, you're still going to have an upward force, but that's going to be pretty small. You can have either of these. It depends upon the initial condition from which height you are dropping the object. So there is no hard and fast rule whether this would be below the x-axis or whether this would be above the x-axis. This could be anything. It depends upon how much mass does the object hits with the ground and what is the mass of that object itself. Do you understand my point?
Yes, sir.
It could be any of those. That's the important bit. It's a good question. Okay, thank you for this. Really good question. Discussable question, to be honest. 44 is also a very nice discussable.
Sir.
Yes.
Oh, sir, you just answered. Okay. No, sir. Sorry.
মানে 44 টা দেখাবো
44 sir.
44 টা দেখাচ্ছি 44 টা আমি ডিটেইলস আলাপ করব এখানে কিছু কোশ্চেন আছে খুব ইন্টারেস্টিং যেমন 47 একটা ভালো ইন্টারেস্টিং কোশ্চেন এখানে একটা কোশ্চেন আছে অনেক mesmerizing for example I think 52 is one of those questions then 53 I like 53 these questions are actually quite interesting there was this another graph which actually was a bit messed up. Let me have a look. This one is also pretty interesting. Where is that graph?
So 19.
Nah, 12. Hold on, 12 parso.
কষ্টই ছিল পারছে
বুঝছো আসলেও
রিঅ্যাকশনের ঝামেলা ছিল
কোশ্চেন 12 টা একটু পড়ো সবাই মানে এটা ওয়ার্কশিটে কোশ্চেন নাম্বার 12 এটা অ্যাকচুয়াল কোশ্চেন পেপার ছিল নাম্বার 10 এই কোশ্চেনটা একটু ভালো করে খেয়াল করো এই কোশ্চেনটা টিপিক্যাল কোশ্চেনের থেকে ডিফারেন্ট I'll tell you why. Have a look. The graph shows a variation with time t of the momentum of a ball as it is kicked in a straight line. Initially, the momentum is p1 at time t1. At time t2, the momentum is p2. What is the magnitude of average force acting on the ball between times t1 and t2? Now, we are definitely gonna use on the lower side to find out the force. There is gonna be difference of time. So the denominator will be definitely t2 minus t1. There is no doubt about that. So A and C are crossed out. They are not acceptable answers. Now, what should be the denominator? Should it be p1 plus p2 or should it be p1 minus p2?
Sir, P1 plus P2, current P2 negative.
Now, that's precisely where you got wrong. I'll tell you why. It's a correct answer B দেওয়া না?
Answer B.
I'll tell you why. এই জিনিসটা খেয়াল করো সিচুয়েশনটা যদি এরকম হতো at t1 time it had a momentum of p1 it was a drawn figure at time t2 in its path as the object was going by after some time t2 at time t2 the object's momentum was in the opposite direction p2 if it was drawn in a figure like this in that case delta p would be definitely p1 minus p2 or you could write p2 minus p2 minus p1 that will be also okay because I'm trying to find out the magnitude that's why I didn't bother for the initial minus final minus initial which should give you p1 plus p2 divided by the time difference is very simple but that's not the case for this question the question has given you a graph where this value is mentioned as p1 this value is mentioned as p2 this p2 over here is not written as minus p2 this is written as p2 the value of p2 would be negative p2 is the sign of that number let's see if this was x this was y the change of momentum would have been x minus y. Whenever you will be placing those numbers, let's say x equals to plus 10 and y equals to minus 10, then ultimately you would do 10 plus 10. But as long as you mention them as your variable sign, you still have to provide what? X minus y. Do you understand my point?
Sir, when a variable দিলে we just
Just
place a variable. We don't bother about the sign
Yes, sir.
before the variable.
You cannot bother about the sign. This number is mentioned as a sign over here. If they wanted you to consider the minus sign, they could have very well written minus p2. They didn't write minus p2. If they did write minus p2, then I would understand that this is the actual scale value of this thing. But they wrote only p2. The value of the p2 would be negative, but p2 itself is not negative. p2 is the sign of this number. So the difference in momentum would be p1 minus p2. B is the correct response, not D. D could have been,
Yes, sir.
if this was not a graph, rather than a drawn figure. If this was the figure, then D would have been a correct answer. It's the same question, but represented in two different ways. So be careful about these things.
Yes, sir.
I want to discuss some detailed things about this one. Have a look at this one. It's a pretty simple question, but I'm going to make it difficult for you so that you understand the whole thing. I mean, not to account of it.
Scare us.
আচ্ছা মেশকাত কি আমাদের সাথে ক্লাস করতেছে না আর? Maybe not. ওকে অনেকদিন দেখি না আমি।
স্যার ও লেভেলস এর অনেকজনই নাই স্যার এখানে।
Yeah, I know that. আচ্ছা
স্যার আপনাকে সবাই ছেড়ে চলে কেন যায়?
আমি ইরেগুলার,
স্যার আপনি রেগুলার হয়ে যান।
irresponsible, impunctual, indisciplined. I pretty much have all the bad qualities that you can possibly name for a human being. I'm extremely
কোথায় স্যার আপনি আমার যত হেল্প করেন,
procrastinating.
আমার তো একটা ভালো ফ্রেন্ড।
আপনার ডেডিকেটেড।
হ্যাঁ স্যার আপনি আমার একটা ভালো ফ্রেন্ড হয়ে গেছেন, কত দেখা গেছে মসজিদ আপনার সাথে, কত কথাবার্তা গল্প।
Well, everyone didn't get that. That's one thing. I'm a messed up person. I have messed up stuff in my brain. Acha, anyway, question number 9. Have a look. A small glider moves along a friction-free horizontal track as shown below. At each end of the air track, acha, there is also another thing that might also be a secondary reason for students leaving me. Apart from me being irregular, that is, many of my lectures are made publicly available on YouTube. Many students feel like that since these lectures are available freely on YouTube, so we're gonna look out for these lectures whenever we have some trouble
Yes, sir.
and because for such lectures are available, so we can actually have the classes by some other teachers, so that we'll be learning from both the teachers. And wow, perfectly okay with me. Just do good results, and I'm happy with that. Anyway,
Sir, probably you can make your videos private.
I do not want to make my videos private.
Why not, sir?
Sir is not arrogant like you.
There is no point in making some learning material private. I don't see the point of it. I mean, well, I'm not. To some extent, you can also call me a hypocrite for that reason, for that choice, but I still don't see the point of it. Maybe I should use that term still. Anyway, let's go for this question. A small glider moves along a friction-free horizontal track as shown below. At each end of the air track, there is a perfectly elastic buffer. Hasan, thank you. buffer, which graph represents the variation with time t of the velocity v of the glider as it moves between the two buffers. Achha. But let me just tell you what air track is. An air track is basically structure, hollow structure like this, where there are small holes over here. There may be multiple holes, there may be one line holes, doesn't matter. This and air is pushed over here through within this chamber at a slight high pressure than atmospheric pressure. This causes air to leak out from these chambers slowly. And if you place some object over here, the outward pressure of the air is capable to hold the object so that it wouldn't contact with the surface. Basically gives you a simple case of levitation. Thus ultimately it causes the friction force that exists between the glider and this triangular track otherwise would be reduced greatly. So for our question over here, we're considering the track to be frictionless, and we're also considering the elastic buffers to be perfectly elastic, which means whenever collisions will happen, all kinetic energies will be conserved. And whenever the glider will travel over the track, there will be no loss of kinetic energy whatsoever. That's the standardized scenario that we are considering. So that's what they are mentioned over here. It's moving along a friction-free horizontal track, and on the two sides we have perfectly elastic buffer. Which graph represents the variation with time t of the velocity v of the glider as it moves between the two buffers? Which one does it show? Now have a look. What this is basically showing us that the glider is going to travel from one end of the air track and it's going to move with uniform velocity from one glider, one track to the other one, and it will make a collision, and then it's going to start moving backwards in the opposite direction. And as long as the glider makes a collision with the elastic buffer, its velocity will change. The moment it loses contact with the elastic buffer, it is going to start traveling over the air track. That is going to cause the glider to move with uniform velocity. So significant duration of the motion would be uniform velocity going back and forth. Very small duration of the velocity of the motion would be velocity change, for which the glider actually collides with the elastic buffers. So the correct response for this question is D, which is basically showing us all of these properties. Uniform velocity, this is the part where it's traveling over the air track. This is the part where it collides with one of the elastic buffers, traveling backwards on the air track, colliding with the other elastic buffer, colliding forward on the track, colliding with the other elastic buffer, and that's how it's going by. Now, this is pretty simple. What I want to handle over here to make these things slightly different, let's say, which one of these answers would be correct if this was not perfectly elastic buffer? Let's say this was not perfectly elastic buffer. সাধারণ কোনটা বুঝে নাই?
স্যার মানে আপনি যে ডিসক্রাইব করলেন যে মানে how it relates with a graph.
Oh, forward direction is given by positive velocity, let's say. Backward direction is given by negative velocity. As long as it is traveling between the two buffers or it is traveling over the air track, we have constant velocity because it is frictionless. And when it is colliding and bumping away, that's when the velocity is changing. That's given by these vertical lines. So all of these vertical lines represents collisions. And all of these horizontal parts represents uniform motion, which is basically the glider moving on the air track, left or right.
মানে sir, this device, I mean, just passes air in such a manner such that air is pushed from one channel to another.
No. So let me show you. Buchi, I got your question now. This is sort of a good image, but not so good image. We have it is exactly the same image that we are handling right now. This is actually The air track is somewhat like this. There are a lot of holes over here. There are a lot of holes over here, and something that is shown well over in this figure. Here you can see that there are a lot of small holes over here. So you can place a small lightweight cardboard piece over here. As air is going to be dispersed out through these small holes, it is going to make the cardboard not touch the triangular side. So it's going to be floating on top of that. Make sense?
The device will be floating, sir.
No, the glider will be floating. So this whole triangular structure basically is a hollow cylinder. One end is totally closed. The other end is connected with a pump that pushes in air into this chamber, and that air is given out through these tiny holes at a low pressure. At a slightly higher pressure than the atmospheric pressure. That's why I'm using the term low pressure. I mean, the pressure difference is not so high. I mean, it just doesn't make a very sharp flow. It slowly squeezes out the air, and whenever we place some light object onto this thing, that air is capable to hold that object, and it actually becomes
Sir,
sort of like a
this
cushion.
thing is just floating on top of this device. I mean, air track.
Yes, precisely. Thus making the horizontal motion back and forth frictionless.
Horizontal motion of air, sir. I mean, motion of the glider, sir, or the air?
We are not showing the motion of the air over here. I'm just discussing the motion of the air to you so that you can make sense of how the glider actually moves. All of these graphs are for the which version of the velocity of the glider. Have you read velocity?
Oh, sir, I mean, we are using the air so that the glider moves in a frictionless manner, and the air buffers, I mean, bounce the glider back and forth.
Precisely, exactly.
Thank you, sir. Now I understood. And because it is frictionless, the size of the size of each graph is, I mean, the same. I mean, the section of the graph.
Horizontal, because there's no velocity drop, and because this is elastic buffer, there is no loss of energy. So the additional part that I wanted to get at, what if this was not a perfect elastic buffer? The correct response for that would be A or B. Now, actual correct response is B. Let me try to understand. Let me help you understand. I'm trying to get to the additional part of the discussion. If these two elastic buffers were not perfectly elastic, which means over the collision, if the buffer did not get all the kinetic energy back, that would mean that the buffers the glider would collide with some high velocity, but it will bounce back with a bit lower velocity, which is perfectly shown in A and B both. But the correct VT graph should be B. The reason that B should be correct graph is, here's the thing. Let's say for the first motion, the glider is moving to the right. It's moving pretty fast. So it is covering the distance from here to here over a short period of time. So this is the distance between the two gliders. After the first collision, it loses some speed, which means the speed by which it does the collision is bigger compared to the speed it gets after the bounce. So the rebound velocity is smaller in magnitude compared to the colliding velocity. That's the key idea for not perfectly elastic buffer. Now you have to understand, as the cardboard will actually move backwards, it has to once again cover the same distance. So this would be the distance in between, and logically these two areas should be equal because we are not moving the elastic buffers. This is the same distance covered over a smaller speed, but the same distance has to be covered, and that's the same thing keep on happening. So this area should also be same. This area should also, all of these areas represent the distance between the two elastic buffers, because the object is losing speed, so it's going to take longer time to cover the same distance. That's what makes B as the correct answer for a not perfectly elastic buffer. বুঝে গেছে? পোলাপান
জি
আচ্ছা now I'm asking you this question, how should the question change, what change should be in the question if A had to be the correct answer? Think.
Sir, the inelastic buffers should come closer to each other.
Very good, perfect answer. A can be happening if the inelastic buffers are approaching towards each other in such a manner that all the collision times are remaining the same. So because you can see over here that this area is bigger, this area is smaller, it's even smaller, even smaller, even smaller, which basically means that the distance that the glider has to travel to make in between collisions has to become smaller, which means that two elastic buffers should get closer to each other. You can keep one stop, one station area and move the other, or you can move both of them together towards each other. Either way you can have that, but the physical meaning of the graph in A means that the distance covered between multiple collisions is becoming smaller. That's the idea. Okay. Next additional part that I want to ask, if this track was not friction free, let's say I'm going to give you this part over here. Let's say if this was a rough track,
Sir, meaning no air track.
maybe there is air, but the air pressure is so low that some part of the glider is, every once in a while the glider is making some contact with the channel. It's not entirely floating. I mean, মানে ধাক্কা খেতে 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 দেখা যাচ্ছে, পুরোপুরি ভেসে নাই। Rough track with elastic buffer, how would that graph look like? Let me just ask you this thing, what would a rough track, what change would a rough track bring about into the graph? What would that do?
Sir, more
স্যার
friction.
লঙ্গার টাইম লাগবে ক্রস করতে আস্তে আস্তে।
Okay, what about the shape change?
স্যার বি এর এক্সট্রিম ভার্সন হবে।
What do you mean by extreme version?
ঠিক স্যার, আরো ফাস্ট স্পিড ড্রপ করবে বি থেকে।
I would say no. I'm looking
ও
for a
স্যার
bit.
স্ট্রেট লাইনস গুলো স্ল্যান্টেড হবে।
Exactly, এখন ঠিক আছে। The horizontal lines will no longer be horizontal lines. Try to understand, what do these horizontal lines represent? These represent uniform motion, frictionless motion from one buffer to other buffer. If the track is of friction, with friction, then what should happen is going to be something like this. You're going to lose some velocity over there. Now, if you have elastic buffer, then the collision velocity, let's say this is the collision velocity and the rebound velocity would be equal. And then you should lose some more velocity. But then again, if these elastic buffers are not getting closer to each other, the area that you show over here should be covered over here as well, which means a longer time would be must be over here. So the area of these two trapeziums should be equal. And then if it gets the same velocity over here, then it should still be losing velocity, covering the same amount of distance, so longer time, so on and so forth. So if you have a rough track, these lines are going to be slanted. If you have elastic buffer, the vertical segment should be equal. If you have not elastic buffer, vertical segments should also become smaller. These are the key variation that you have to understand. There can be lots of hodgepodge and mix and matches to give you different type of graphs, but as long as you understand which property controls which part of the graph, you can manipulate all the other variations as well. বুঝা গেছে?
Yes, sir.
Yes, sir.
Mm. $44. 44 is a nice question. A ball is released from rest on a smooth slope xy. It moves down the slope along a smooth horizontal surface xy and then rebounds inelastically at z. So try to understand. The ball is released on a smooth slope. It moves down the slope along a smooth horizontal space. So which means xy is smooth, yz is also smooth. It rebounds with z, but that collision is inelastic. Then it moves back to y and comes to rest momentarily somewhere on xy. So it then moves backwards and somewhere on xy it comes to a stop. Which VT graph represents the motion of the ball? Which one do you think is the correct response? There are multiple things to observe over here. Okay, first thing that we can also definitely understand that if it is an inelastic collision, the colliding velocity would be bigger and the rebound velocity should be smaller. এটা তো বুঝতেছো, যেটা একটু আগে বললাম।
Yes, sir.
তাহলে আমাদের ডি বাদ, তাহলে বি এ বি সি এর মধ্যে কোন একটা কারেক্ট আনসার হবে। এটা 1 নাম্বার। 2 নাম্বার হচ্ছে the second thing is that whenever the speed would be reduced, the amount of time it would take to cover yz, I mean going this way, it should definitely take longer time to go in zy direction because it has to cover the same horizontal distance, which is frictionless, but the requirement of time should be bigger because it has to cover the same distance, which means B cannot be the correct answer because B shows these two time durations are nearly equal. A and C shows that the backward movement takes longer time. ঠিক আছে? আচ্ছা, the next part is that
Sir,
হ্যাঁ বলো,
কেন ইকুয়াল হবে না স্যার টাইমটা?
because you are covering the same distance with a smaller speed.
ওকে স্যার, স্যার।
বুঝছো? distance constant, speed যদি কমে যায় তাহলে টাইম বাড়তে হবে যদি প্রোডাক্টটা সেম থাকে। আচ্ছা, then comes the idea that for this last segment between this and this gradient, which one should be the acceptable one? Now try to understand this thing. Whenever the ball was released from here, there was a certain component of gravity which was working for the acceleration of the ball along this track. I can actually show you this part. For example, let's say if you consider theta over here, let's say this angle is theta and G working over here is theta, and let's say this angle would also be theta. Sorry, theta. So in this direction, G would be, so this would be theta as well. So this angle, this should be G sine theta. And so this is the component of G that would be causing the ball to accelerate along xy. When the ball is going to start go in the y's direction, that same exact component of G would be responsible to slow it down because the angle is remaining the same. Essentially, the angle is remaining the same. So this would cause the same deceleration. So the rate of velocity increase that happened along xy would be the same as the rate of velocity decrease along that in the direction yx, which means these two sides should be what? Parallel.
স্যার কাজ করতে পারলি স্যার, কেন প্যারালাল হবে?
Because the component of gravitational acceleration that is causing the speeding up in the xy direction would be the same component of gravitational acceleration which will be causing the deceleration in the yx direction, because the slant is very much the same.
Yes, sir.
So because the slant remains the same, that's why these two components should be exactly same, which means the acceleration and in this case deceleration, I mean slowing down, that should have the same gradient. That's why A is the correct response. These two sides should be parallel. Now the question that I want to ask you, what if this surface was rough? If xy was rough, let me draw that with red. If xy was rough, then which one should be your correct answer?
স্যার শুধু XY গ্রাফ আর YZ নরমাল।
হ্যাঁ, শুধু ওই একটা ওয়ার্ডই চেঞ্জ। A ball is released from a rest on a rough slope xy. It moves down the slope and blah 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 blah.
সি হবে।
ইয়েস স্যার।
সি হবে। এখন কেন হবে এটা কি বুঝতেছো?
এ হবে।
ফ্রিকশনের জন্য আরো তাড়াতাড়ি মানে ডিসেলারেশন হবে।
এক্স্যাক্টলি। এ তো আমাদের স্মুথ স্লোপের জন্য অলরেডি ছিল। এর কনসেপ্ট
কিন্তু অ্যাক্সেশন তো সেম।
এই কনসেপ্টটা হচ্ছে অ্যাক্সিলারেশন দুই পাশে সেম। স্পিডিং আপ যে রেটে হয়েছিল ফল করার সময়, উপর ওঠার সময় স্লোইং ডাউন একই রেটে হয়েছে। বাট option 2C shows us that whenever the ball is going to start rising up, it's going to decelerate more rapidly. That is possible if you have a rough plane. So when the ball is falling down, the acceleration is working against the motion, but because gravitational acceleration component is stronger, it's gonna keep falling down. So you have some actual acceleration for the falling part. But when the ball is gonna start to rise up, G is gonna start pulling it back. The friction is also gonna start pulling it back, which means your resultant backward acceleration will be definitely stronger compared to the resultant forward acceleration in the first part. That's why C would be the correct response if the question told us it was for a rough slope xy. বুঝা গেছে কি?
জি স্যার।
ইয়েস স্যার।
আচ্ছা, next part. What if they
স্যার
told
একটা
us,
কোশ্চেন আছে স্যার।
একটু দাও, এক মিনিট, what if they told us this is a rough slope, this is a rough slope, try to understand this part, this is a rough slope and the collision was elastic. If they bring about these two changes, then what?
ডি।
স্যার ইয়েস স্যার, বি স্যার। Oh no sir, not B sir. I mean it's supposed to be something like B but with
The last part more steeper.
yes sir. I mean sir. Oh sorry sir, D. Yes sir, sorry D sir.
বুঝছো বলবান?
Yes, sir.
আচ্ছা, আমি একটা পার্ট নিয়ে এখনো কথাবার্তা বলি না, সেটা হচ্ছে what if they tried to change the description of this part, smooth horizontal surface yz, এটাকে যদি রাফ বলতো তাহলে আমাদের গ্রাফের কোন সেগমেন্টটা চেঞ্জ হতো?
ফার্স্ট এর ওই হরিজন্টাল লাইনটা।
দুটো হরিজন্টাল লাইনে চেঞ্জ হতো। both of these horizontal lines should
জি স্যার।
should be of they should become slanted towards the x-axis. If yz or zy path were somewhat rough, then that would mean that from this point the velocity would not be constant, the velocity would be dropping somewhat, and then the collision should happen, whether elastic or inelastic depending upon your question. If it's elastic, then you should have equal drop and equal rise. I mean, collision velocity and rebound velocity should be same. If it is inelastic, then it should be less. But then again, as it goes up, এই পয়েন্টে আমাদের স্পিডের ড্রপ হতো. So that's the idea. If flat surfaces are rough, then you're going to have these kind of changes. তোমরা তো পাওয়ারের ফর্মুলা জানো, তাই না?
Sir, energy by time sir. And the other one is velocity. Sorry.
তোমাদেরকে আমি দুটো এমসিকিউ ট্রাই করতে দিব, দাঁড়াও দেখি এখানে আছে কিনা, থাকলে তো ভালো।
Sir, O levels এ যেহেতু স্যার সিলেবাসটা চেঞ্জ হয়েছে স্যার, so for the cover up for the new part, how I mean how will you sir I mean provide worksheets?
দাঁড়াও বলতেছি।
স্যার আমাদের কি ও লেভেল সিলেবাস এখন করতে হবে স্যার? আগের ব্যাচে আগে এই ক্লাস 10 এর
না, ওগুলো তোমাদের এএসএস সিলেবাসে ঢুকাই দেওয়া হয়েছে। As far
জি
as I
স্যার,
know.
ওটাই তো ভাবতেছিলাম স্যার, এটা তো করার কথা না।
আর স্যার অ্যাস্ট্রোনমির পার্টটা স্যার আমরা কিভাবে কভার আপ করবো স্যার?
পড়াশোনা করে।
আই মিন স্যার ওয়ার্কশিটটা স্যার, ওয়ার্কশিট সলভিং
তোমরা অবশ্যই করবা।
স্যার আছে স্যার আমাদের এই বান্ডেল।
আইজিসিএসসি থাকতে পারে স্যার।
আমি এখনো দেখি নাই, আমি একটা স্পেসিফিক জিনিস খুঁজতেছি, দাঁড়াও।
স্যার এরিক্স লেক আছে? এর জন্য
আচ্ছা, so we just started the recording. Acha, so now we just discussed that how this graph is going to look like. What we discussed over here for multiple things, that the horizontal axis was x-axis, and we discussed over here that if we had multiple variables and with multiple different axes, if the axis had a constant multiple with it, then the graph shape would remain the same. So what we propose that the graph shape for v versus x is only a constant multiplied by t, should have the shape very much similar to v versus t, because x proportional to t, the vt graph and vx graph should have the exact same shape that is. So that's why our correct response for this question was D. Then we discussed that if we are trying to plot the magnitude of vertical component of velocity with respect to x, there should be straight lines of equal gradient, magnitude gradient, and it should start from a small value, become 0, and then eventually it will become positive and go up. The part that we are currently at is that if we try to plot vx versus x, how would this graph look like?
Sir, horizontal line parallel with the x-axis.
Beautiful. Constant vx. Do you understand why?
Sir, with horizontal
Yes.
component to constant and is not like result or like based on or dependent on the acceleration vector, and acceleration due to free fall vector.
Beautiful. Perfect answer. So এটা হচ্ছে এরকম। আচ্ছা, now I'm going to add two more a condition and then we'll call it a day for today's class. সেটা হচ্ছে, what if they asked us this question for considering air resistance? We have air resistance. If we did have air resistance, how would this graph change?
Sir, Vx like Vy, sir.
I can help you with the Vx. Vx would simply have a bit of a downward curve. This curve should be losing gradient. I mean, the Vx curve would be somewhat like this. As you slowly slow down, you're going to be losing less velocity, but this is going to be asymptotic graph with the x-axis. I mean, if you are going further, you'll be losing more velocity. There is nothing to add up to your velocity, so that's why it's going to become a decreasing gradient asymptotic curve with the x-axis. How about for the Vy graph? How would the Vy graph should look like? Think about it.
Sir, Vy graph to prothome positive hobe because of air resistance with a decreasing gradient. Pore Vy kombe, like it will become negative, but the air resistance will act in the opposite directions, but to the velocity vector, which will cause the velocity vector to slow down faster, sir, or become
Okay, slow down
closer
faster.
to zero.
Slow down faster. Good. So how would the gradients look like? I mean, which segment would have a steeper gradient?
Sir, second sir, কারণ সেকেন্ডে যত ভেলোসিটিটা বাড়বে নিচে গেলে তত বেশি এয়ার রেজিস্ট্যান্স।
ফার্স্ট বেস স্টিপ হবে না?
In my opinion, the first part should be steeper. I'll tell you why. For the rising part, try to understand this thing. For the rising part, both the weight is working downwards, air resistance will also work downwards. But for the falling part, weight will be working downwards, but the air resistance will be working upwards. So here, the deceleration or downward acceleration magnitude will be bigger because both the forces are working downwards. Here, the forces are working in opposite direction. So your steepness would be less over here. So if you ask me, obviously these things are going to be curved. Definitely these things are going to be curved. So I might actually draw a curve over here, decreasing curve or
আচ্ছা স্যার একটা কোয়েশ্চেন ছিল স্যার
okay, if
Sir.
I don't want to draw them with curves, if I consider a constant air resistance, because drawing a curve would be actually need a differential equation, this part would be steeper and this part would be slanted. Okay, if I want to draw a perfect curve, this might actually look like this.
স্যার এয়ার রেজিস্ট্যান্স তো সবসময় ওয়েটকে অপোজ করে না, it always opposes motion, right?
Not weight, it always opposes the instantaneous velocity.
জি স্যার বুঝছি। Is the resultant instantaneous velocity?
That would also be slowly becoming less. Resultant velocity would not actually become zero. I mean, it doesn't essentially have to become zero. I mean, resultant velocity would actually try to reach a constant velocity. For example, if this x distance was infinitely large, and air resistance was considered to be a significant force, this graph would slowly become terminal velocity, right?
Yes sir.
That's what I'm trying to show. So that's basically what I drew over here. I actually showed it to be increasing gradient. For the first part, it can be increasing, and then it should actually become like that. I'm not very sure about this, but this would have definitely stronger gradient on the rising part and less gradient on the falling part, because at this part the forces are both working upward direction. Here air resistance is working in the upward direction, but ulta will see here both the forces are working downward direction, and for this case air is working upwards and weight working downwards, so here the acceleration will be somewhat less. তোমাদের এত ডিটেইলস এর কোশ্চেন আসবে না, আমি এত ডিটেইলস এ বোঝানোর কারণ হচ্ছে যাতে করে তোমরা গ্রাফের পসিবল ম্যানিপুলেশন গুলো ধরতে পারো, যাতে করে এই জিনিসগুলো কনফিউজ না হয়। কারণ this kind of questions can prove to be pretty simple if you understand the concept. You can choose the answer very easily. But if you don't understand the concept, for example, many of you actually might have not even considered the fact that the horizontal axis was x. You might have got the answer right, but you didn't even bother, or you didn't. This actually really, I mean, didn't even catch your eyes that the horizontal distance over here was x. You might have assumed it as v versus t. Both the graphs would be same, but you need to know the logic why the graphs are supposed to have same shape. Okay, that's all for today's class. তোমরা P2 গুলো অ্যাটেম্প করো, আমরা নেক্সট ক্লাসে P2 ডিটেইলস প্রবলেম গুলো সলভ নিয়ে আলাপ করব। তোমাদের সাথে আবার মঙ্গলবার দিন দেখা হবে ইনশাআল্লাহ। আসসালামু আলাইকুম।
স্যার
স্যার আল্লাহ হাফেজ স্যার।
স্যার যে এক্সট্রা ক্লাস স্যার আপনি যে বলেছিলেন স্যার, ওটা কি গ্রুপে ডিসকাস করব?
এক্সট্রা ক্লাসের টাইমিং তোমরা গ্রুপে একটু ডিসকাস করে টাইম বাই করতে ভালো হয়, স্পেশালি হচ্ছে বৃহস্পতিবার সকালের দিকে হলে আমার জন্য সবচেয়ে ভালো হয়।
ওকে
আচ্ছা, আল্লাহ হাফেজ।
স্যার এই উইকে
আপকামিং উইকে আই ডোন্ট মাইন্ড।
ওকে
স্যার ওয়েডনেসডে তে করা যায় স্যার?
ওয়েডনেসডে আমার 1টা থেকে ক্লাস আছে।
তো একটা সকাল 1টার আগে স্যার?
আর সকাল 8টার আগে কেউ উঠবে না, আনরিয়েলিস্টিক চেষ্টা করে লাভ নাই। সো I mean, the earliest you can start is 9. I think that's more or less standard.
স্যার আমরা তো কোচিং এর 8:30 দিকে আসছি।
I'm talking for everyone, including myself.
Oh, sir.
Okay. Assalamu alaikum.
ওয়ালাইকুম আসসালাম।
আসসালামু আলাইকুম স্যার।
Walaikum assalam.